asks us to find the derivative of a function and then use that to show that the integral is equal to that function, and then hence we can find the definite integral. So basically it's reinforcing the idea that when we find the integral, we're actually finding what's called the antiderivative. So the function that we actually have to differentiate to get ln x. So let's have a look. So we've got to find the derivative of x ln x. Now, derivative with respect to x of x ln x. Now, from our work we've done with calculus and with derivatives, we know that this is a product rule question. So here is my u, and here is my v, and the derivative with respect to x of uv is equal to u v dash plus u dash v. So here's my u is x, so it'll be x, and the derivative of ln x is 1 on x, because the integral of 1 on x is ln x from our table, so the derivative of ln x is 1 on x, so there's my u v dash plus u dash. The derivative of x is just 1 times ln x. Now that's equal to 1 plus ln x. So that's the derivative with respect to x of x ln x. So if the derivative of x ln x is equal to that, then the integral of this must be equal to that. So say it again, that if the derivative of x ln x is equal to this function, by the fundamental theorem of calculus, the integral of that must be equal to that. So therefore, the integral of 1 plus ln x dx is equal to x ln x. When we integrate this, we can integrate each of the individual components, and we can say that that's the integral of 1 dx plus the integral of ln x dx will be equal to x ln x. Now what's the integral of 1 dx? That's just x plus, this is what we're asked to find, the integral of ln x dx will be equal to x ln x. Now the integral of 1 can be x, or x plus c if you like, when we do the indefinite integral. So therefore when this comes over the other side, we've got the integral of ln x dx is equal to x ln x. The x comes over, it'll be minus x. Now c is just a constant, it could be plus or minus, we're just saying it's a constant, so we can say that's equal to plus c, where c could be some negative value, or it could be positive. All we're saying is just a constant. So we don't have to say minus c here, we just say plus c where c could be negative. So that's done this step here. So we've used the fact that the integral of this is equal to that. And now the third bit is to find the integral between 1 and 3. So we're going to find the definite integral. So therefore the integral between 1 and 3 of ln x dx will be equal to, we'll just pick up the definite side, so that'll be x ln x minus x, and that'll be between the values of 1 and 3. So that's equal to 3 ln 3 minus 3 minus, so we put in the 3 values, 1 ln 1 minus 1. And here we get a value. When you put those values into your calculator, you'll get a value of 1.2958. Okay, so this is just reinforcing the idea that when we integrate, you're finding the function that you had to differentiate to get that function that you're trying to integrate.